Welcome to our YouTube channel. My name is Colin Hyatt and I'm a battery technician here at Polaris Battery Labs, and today I'll be going over some of our best practices and tips for punching battery electrodes using some custom fabricated steel rule dies and a pneumatic press. So one of the things that we look out for when we're punching electrodes is to ensure that our anode is sized larger than our cathode. Specifically, we size it so that there's at least a 0.5 millimeter reveal around the active area of the electrode. So specifically, this rectangular space within the electrode, and that's to ensure that we avoid any potential shorts that may occur from current collector interaction between the cathode and the anode. Secondly, what we like to do is we like to have different tab shapes specific to the electrode. So for cathodes, we have a more rectangular shaped tab, and for anodes, it's more of like a triangular, trapezoidal shape. Just to, even though they're different current collector materials, this definitely helps to distinguish which electrode belongs to which side. In a typical coat run, we coat to meet a specific loading target. Ideally, what we would like to see is a loading that is consistent along all along the coat. In reality, what happens is we get a little bit of bleed on the edges of the coat, in which case there tends to be a slight inconsistency in not only the thickness but the overall mass loading along the entirety of the coat. So what we do to ensure that we're getting consistent loading in each of our electrode punches is by not only taking mass measurements of the electrodes, but also by taking thickness measurements of those electrodes to ensure consistent thickness along the electrodes. So lastly, one major important thing that we tend to look for is, are we achieving an adequate N/P ratio? Essentially, do we have more than enough vacancies in the anode material for the capacity that the cathode is providing? And how we typically do that is through the areal capacities of the cathode versus the anode, and that's largely determined by the mass loading of each of those materials and the specific capacities, first charge and reversible capacities of those materials. Oftentimes, when working with new clients, we'll get materials that we don't know a whole lot about, in which case some initial experiments are done to determine those specific quantities, and then we can match appropriately. Alright, and that's it. And so once the electrodes are punched and weighed, we can then move on to calendaring, where we start to explore material density and target porosities. Catch that in our next video.